going to determine what kind of response your system has. So if you've got a damping ratio greater than or equal to 1, then you're going to have an overdamped system, and it's going to have a stable monotonic response. If you've got a damping ratio that is between 0 and 1, you're going to have an underdamped system, and it's going to have a stable oscillatory response. If you've got a zeta value that's between -1 and 0, it's going to be unstable, and it's going to grow without bound in an oscillatory manner. And if you've got a zeta that's less than -1, then it's going to grow without bound in a monotonic fashion. And you're going to see some graphs. I'll show you some graphs. So this is the zeta between 0 and 1 type of response. This is response with the blue curve. That's a value of zeta that's greater than or equal to 1. Then this is unstable. This is a zeta between 0 and -1. And then this is unstable. It's a zeta value less than -1. And so once we put together the root locus plot, these are the sort of values we're interested in getting. These are various controller gains. KCD is the highest value that's going to give you, basically this is going to give you a monotonic stable output. So this is a critically damped. And if you have a KC value that's less than KCD, then it's going to be overdamped. And KQD is the one-quarter decay, and so that's going to be an oscillatory response. And KCU is going to be the highest KC value that gives you an oscillatory stable output. So anything greater than KCU is going to give you an unstable response. And so this is just how you find the KCD and the KQD and the KCU on the root locus plot. And so I'll just show you that on the plot. Here's our root locus plot. And so here's the KCD. Any controller gain value that's on this range is going to be an overdamped response. Any controller gain value that's along here before you get to the axis is going to be an underdamped response. And then any controller gain that's beyond the axis is going to be an unstable response. And so here are the values we got for KCD, KQD, and KCU. And all of the controller gain values that we're looking at are shown here. So this is the total results, where we've got an ultimate controller value of 0.95, quarter decay of 0.39, 1/10 decay of 0.31500, decay of 0.14, and the critical damping controller gain of 0.07. And so these are the ranges for an underdamped response and an overdamped response. And all the units of the controller gain are in percent per RPM. And so in conclusion, if you want an overdamped response, you need a KC controller gain value that's in this range, 0 to 0.072. If you want a critically damped system, you need a controller gain of 0.072. If you want an underdamped system, you need a controller gain of 0.072 to 0.59. And if you want a response that's quarter decay, you need a controller gain of 0.39% per RPM. Are there any questions?